Let's now look at finding the zeros of a quadratic function algebraically. I'm sure that you have all done this particular process before, so let's refresh our memories on what it is we need to do. So I'd like to find the zeros first of the function f of x is x squared minus 3x minus 10. So to find the zeros, remember we said earlier we would set the function equal to 0. So we do 0 equals x squared minus 3x minus 10. This particular function we can solve by factoring, and if we factor we get x minus 5 multiplied by x plus 2. And when we set each of the factors equal to 0, we get x equals 5 or x equals 2. And so this particular quadratic function has two zeros. One of them would be at negative 2 and the other would be at positive 5. Now, of course, we know there are times when we can't solve a quadratic equation, a quadratic function for 0 by factoring. And hopefully what you remember is in order to do that, you can use the quadratic formula. And so the quadratic formula tells us that the roots or the zeros of a quadratic function are given by x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This formula is often called the quadratic formula. And we call the term b squared minus 4ac the discriminant. The discriminant is important to us because it tells us how many roots a quadratic function has. Specifically, and I'm sure many of you remember this, that if b squared minus 4ac is less than 0, there are no real roots. If b squared minus 4ac equals 0, there is one real root. And if b squared minus 4ac is greater than 0, there are two real roots. So what we're going to do is we're going to examine each case, each situation, individually. So let's first look at case 1, no real roots. As we just said, if the discriminant of a quadratic function, remember that's the b squared minus 4ac, is less than 0, then the function has no real roots, and the parabola it represents does not intersect the x-axis. Since the quadratic formula requires taking the square root of the discriminant, remember a negative discriminant creates a problem because the square root of a negative number is not defined over the real line. It's what we call imaginary. An example of a quadratic function with no real roots would be given by this f of x is x squared minus 3x plus 4. And notice when I do the discriminant, b squared minus 4ac, I would have negative 3 squared minus 4, and a is 1, and c is 4, so I end up with 9 minus 16, which is negative 7. This function is graphically represented by a parabola that opens upward, right, whose vertex lies above the x-axis. Thus, the graph will never intersect the x-axis and has no roots. Let's take a look at case 2, when we have one real root. If the discriminant of a quadratic function is equal to 0, then the function has exactly one real root and crosses the x-axis at a single point. What's kind of interesting is if we realize this, if we have something whose discriminant is equal to 0, then what happens is under the square root we have a 0. So our quadratic formula would become negative b plus or minus the square root of 0 all over 2a, and we would end up with negative b over 2a, or the negative of b over 2a. That will become important to us later on in the section in the chapter. Lastly, let's take a look at case 3, two real roots. If the discriminant of a quadratic function is greater than 0, the function is going to have two real roots, or x-intercepts, or zeros if it's a function. Taking the square root of a positive real number is well defined, and the two roots then would be given by negative b plus the square root of b squared minus 4ac over 2a, and negative b minus the square root of b squared minus 4ac all over 2a. An example of a quadratic function with two real roots is given by 2x squared, f of x equals 2x squared minus 11x plus 5. Notice the discriminant is greater than 0, because if I did b squared minus 4ac, I'd have negative 11 squared minus 4, and then my a is 2 and my c is 5, and I'd end up with 121 minus 40, or 81. And then the function here would be graphed as a parabola again that opens upward and whose vertex would lie below the x-axis. Thus the graph would intersect the x-axis in two places. Would have two roots or two zeros, and I illustrated that in the graph below.